Okay guys, we're going through 6-5 today, and in this section we are discussing amplitude and period. So in this section we begin to start looking at the graphs of sine and cosine. And so here we've got the graph of the equation for sine y equals sine x. Alright, and this one is the equation for y equals cosine of x. And we have also a chart down here that we're going to look at in a minute that kind of pinpoints the various differences in each one of them. And so just very quickly, when we're talking about amplitude and period, so amplitude is going to be the height of the wave, right? So in this case it would be 1, or more specifically it's half the distance between the minimum and maximum value, right? And the period is going to be the amount that it takes to make one full cycle. So in both cases, for sine and cosine, one full cycle is completed at 2 pi, right? So 2 pi would be the period in this case as well, to complete a full cycle of sine and cosine. And the amplitude for cosine is also 1 in this equation. All right. Now, well, let's look at some of the characteristics first. Okay, so again, I've got the two graphs here, and here are some of the characteristics for these two functions. When we're talking about sine, the domain, all real numbers. Okay, so anything you want can plug in for x, right? Now the range, the output value that you get, it's got to be between -1 and 1, because remember, this function is cyclic and it just kind of cycles between the values of 1 and -1. And the period we also discussed is 2 pi. So once it gets to 2 pi, it's made a whole complete cycle of the wave, right? The x-intercepts now, it does have multiple x-intercepts. As a matter of fact, infinitely many x-intercepts, which can be expressed as any multiple of pi, right? So n pi, comma 0, those are your x-intercepts. Meaning I could plug in 0, and that's an x-intercept. I could plug in 1, 2 pi, 3 pi, 4 pi, 5 pi, and so on, and those is where it hits the x-axis. Now there's just one y-intercept, and that's at 0, 0. And the sine is an odd function because of the fact that it has origin symmetry, right? And of course, there's an algebraic definition for odd function that you can go back and look up from last semester too if you need to. And so for the cosine of x, we kind of have the same characteristics listed out. The domain is all real numbers. You can plug in whatever you want for x. The same range from -1 fluctuates from -1 to 1. Period is also 2 pi to complete a full cycle of the wave. And the x-intercepts, though, differ a little bit. It's going to be the same in pi, but it's going to be shifted by pi over 2 units, right? And so if you kind of take a look at where the x-intercepts are in the cosine function as opposed to the sine function, okay, you can get them by adding 2 pi, adding 2 pi from a previous one from the sine function, right? And so instead of hitting at 0 pi, 2 pi, it hits at, pi over 2, let's see, so that'd be pi over 2, that'd be 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, it would hit again. All right, so you're just shifting that by multiples of pi over 2, right? Or let's see, what else? Y-intercept at 0, 1, and this is an even function because it has symmetry through the y-axis. All right. Okay, so more specifically now, we're looking at the definition of amplitude. So if you've got equations, sine and cosine equations in this form, all right, remember the amplitude, I think like we mentioned before, represents half the distance between the minimum and maximum values, and it's given by the absolute value of a. So whatever your a is here, that determines your amplitude. So if you want to increase the amplitude of the wave or the height of the wave, then you can do so by changing this number on the equation. And we're going to get into a section where we look specifically at graphing these functions, right, and how changing the graph affects, or changing the equation affects the graph. But right now we just need to know that the absolute value of this number, that's your amplitude. All right. Let's see. Now let's talk about how we would calculate the period. And so B is going to be, let B be a positive real number. And the period, with equations given in this same general form, is equal to 2 pi over B. So it's 2 pi, whatever the normal period is, and then you divide that by B to account for whatever change you're making here in this equation, right? Because remember, y equals sine of x has a period of 2 pi. We looked at that on the graph on the other page. However, if you change this value of B to something other than 1, that will alter the period. It will change how fast the graph makes one complete cycle, in other words. And I'm just throwing this in here also. I know for this definition it says let B be a positive number, but if you do run into some situations where you've got a negative number in here, then when you calculate the period, you just take the absolute value of that number so that the period is always positive, right? Okay, so let's do some examples here and see what we can come up with. So with this one, we're asked to find the period and the amplitude here. So here's my equation, y equals 2 cosine 3x. And so if I want to find the period, let's start with that. Okay. If I want to find the period, remember period is 2 pi over b, 2 pi over b. So that would end up being 2 pi over, well, the value of b in this case is 3, so I'm going to make that a 3. And there's nothing else to solve. That fraction doesn't reduce, and then so that's your answer. So that would be the period for this one, 2 pi over 3. So instead of completing in 2 pi like the sine over like the sine of cosine x does, it completes its full cycle, the full curve, right, at 2 pi over 3. All right, so it finishes a third of the time, right, because you're multiplying this by 3. All right, now the amplitude is going to be the absolute value of a, which is 2. All right. So here's how you can kind of think about it. This number is affects the amplitude, how tall the wave is or how high the wave gets. This number, all right, increases the speed by which it completes a cycle, right? So it will complete a cycle 3 times as fast as what it normally would in 2 pi, at 2 pi. All right? Okay, next one. Let's take a look. All right, so I'm looking for the period again, and so remember, we know that the period is 2 pi. And I'm going to stop right there because my value of b is 1, so it'd be 2 pi divided by 1, which we know is just 2 pi. And so again, quickly by looking at that equation, that number is a 1, so the period is going to stay as 2 pi. What about the amplitude though? The amplitude right here, we can use this value, is -2, is the value of the a here. But remember what amplitude is, it's the absolute value of that. So instead of -2, we're just going to call it 2, because the amplitude is always expressed as a positive number. Let's go to the next one. What about if I want the period here? Okay, so let's talk about it. Period is going to be 2 pi over what? Over b. So the question becomes, what's my b here? Okay, so as we're looking at it, remember the b is the coefficient of the x, which is going to be pi over 2. Okay. Now I'm ready to multiply this out by the reciprocal, so I'll go 2x over 1, reciprocal of the denominator, I should say. So that would be 2 over pi. Alright, so we got that. And so in order to finish that out now, the pi's are going to cancel out. And so 2 times 2 will make 4. So 4 is what we've got there for an answer. Let me see. Next one, the amplitude. of course, is 3 over 2. All right. One more we do want to take a look at. That's this equation. Let's start with the period. And so, again, my period is going to be 2 pi divided by the value of b, which is 2/3. So I'm going to divide that by 2/3. And I'm ready now to say we've got 2 pi over 1 times the reciprocal of the denominator, 3 over 2. Alright, and so with this now, the 2's will cancel, and then that'll leave me with 3 pi. Okay. Amplitude, of course, can be just read off from this value, 1/4. And that's it. That's all there is to it.